Okay, so we are working on page 13 of our Unit 9 course pack. And for class today, you're just going to complete numbers 1 and 2 with me on this ed puzzle. And then numbers 3 and 4 you will do on your own and just do your best. Try to think through them, put on those critical thinking skills, and see if you can figure out how to answer them. They won't be graded for accuracy, so just do your best, and then we'll go over them next class together. But let's just start with number 1. So just to review, we learned in our lab that at standard temperature and pressure, which on the back of your periodic table, you can look and it will say standard temperature and pressure. What does that mean? That means 273 Kelvin, not degrees Celsius, but with all of these, we're working with Kelvin. And pressure, which is 1 atmosphere or 760 millimeters of mercury. So anytime we're at that standard temperature of 273 and the pressure of 1 atmosphere, any mole of a gas takes up the same amount of volume, and that volume is 22.4 liters per mole. And so we're going to use this value to figure out how much of a gas we have at standard temperature and pressure. So let's look at number 1. It says that solid lithium reacts with liquid water in a single replacement reaction, forming hydrogen gas and aqueous lithium oxide. So let's take a minute to just write out our equation. So we have lithium reacting with water in a single replacement reaction to form hydrogen gas, which remember is H2 because it's a diatomic molecule, hydrogen gas, and aqueous lithium oxide. So remember, lithium has a +1 charge and oxide has a 2-. So that means that we are going to need 2 lithium, 2 +1 charges to cancel out that -2 charge. So we have Li2O aqueous. Okay, and then to balance this, we just have to add a 2 in front of the lithium and we're good to go. Okay, so it says that how many grams of lithium must be added to water in order to release 15 liters of hydrogen gas at standard temperature and pressure. So it's basically asking how many grams of lithium are going to react, or in our BCA chart, the C, how much of that needs to react in order to release 15 liters of hydrogen gas. So say you're in the lab and you need 15 liters of hydrogen gas, and they're like, how much lithium do we need? So, and you can actually calculate this number. So you use your conversion, 22.4 liters to moles, to figure that out. So we start with 15.0 liters, and we want to convert to moles. So basically the process is going to be liters of H2 to moles of H2, and then from moles of H2, we can figure out moles of lithium using our BCA chart. And then once we find moles of lithium, it asks for grams. So then we just have to convert moles of lithium to grams of lithium. So in order to do our first step, which is just converting liters of H2 to moles of H2, we use our 22.4 liters per mole. And we're going to use our T-chart, or you can also write it just as, like, I've heard this called like train tracks, or yeah, whatever works for you. I like the T-chart just because it looks neater. So you have 15 liters of H2. So make sure you always have your units and then the element that you're working with. So we have 15 liters of hydrogen gas, and we want to end up at moles of hydrogen gas. And so we need these liters to cancel out. And so that means that our liters is going to go on the bottom so that it can cancel out. Because anytime I have something in the top and the bottom of my T-chart, they cancel out. So liters of H2, and this conversion is 22.4 liters to 1 mole of H2. And so then when I put that into my calculator, I'll get 15 divided by 22.4. And that will give me 0.670 moles of H2. Okay, so now we did our first step. Second step is going from moles of H2 to moles of lithium. And for that, we're going to need to use our BCA chart. So we know that 0.670 moles of H2 gas are formed. And because H2 is a product, that means it started at 0 moles because before the reaction has started, nothing has been produced. So that means that our change must be 0.670 moles as well. And looking at my coefficients, it's a 1:1:1 ratio with water and lithium oxide. So that means that this same value is going to be the change for these as well. So 0.670 moles, I can fill that in for water and lithium oxide. And lithium oxide also started at 0 moles, so I'm going to end up with the same amount. My hydrogen or my water was in excess, so I can just write excess minus 0.670 moles. Okay, so now to lithium. You'll notice that lithium and hydrogen are a 2:1 ratio. So that means that for every 1 mole of hydrogen that is formed, 2 moles of lithium reacted. So I just need to multiply my change of hydrogen by 2, and that will give me 1.34 moles of lithium reacted. And I started with 1.34 moles of lithium because it is our limiting reactant, so I will end up with 0. Okay, so this number right here, I've now found moles of lithium that is added to water. So I did my second step, check. Now I just need to convert moles of lithium to grams of lithium. And the way that we do that is, again, just with our T-chart. So I have 1.34 moles, and I want to cancel out the moles, so I'll put moles at the bottom here. And then my unit that I want to end up with is grams, so I'll put grams at the top. And for this, I'm going to use the molar mass of lithium. So for every 1 mole of lithium, there is 6.94 grams of lithium. So now I'm just going to multiply those two numbers together. And my final answer is 9.29 grams of lithium. So notice I have 3 significant figures because my value 15.0 has 3 sig figs. So my answer should also have 3 sig figs. I also want my gram, my units, and then the label of the units, so grams of lithium. So you need all 3 of those in your answer. Okay, so let's go ahead and go on to number 2. Here we have 224.5 grams of argon gases contained inside a 15-liter steel cylinder at a temperature of 24 degrees Celsius. What is the pressure inside this steel cylinder? Okay, so the first thing that you want to notice is that these conditions are not at standard temperature and pressure. So my standard temperature is 273 Kelvin, which if I were to write that in degrees Celsius, it would be 0 degrees Celsius. But this is 24 degrees Celsius. So if I convert that to Kelvin, I just have to add 273 plus 24, and I will get 297. Okay, so that's not standard temperature and pressure. So I can't just use this conversion right here to calculate. I need to use my equation, which is PV equals nRT. Okay, and just a reminder, my pressure is, or my P stands for pressure at ATM. My volume, or the V stands for volume in liters. N stands for number of moles. And then the R comes from the back of the periodic table. In the same box that you see STP information, it will have the R, which is 0.08201 liters per ATM per moles of Kelvin. And remember, it's important that these units are really important, because if I put in grams into this equation, put something like if I just take this grams of argon and plug it into my equation, I'm not going to get the correct answer. I have to make sure that everything I plug, all the numbers I plug into the equation, have these same units. So my temperature, I can't plug in degrees Celsius. I have to first convert it to Kelvin in order to get the correct answer. Okay, so with that, we have we pretty much have every value that we need except for pressure. So we have volume right here, we have temperature here, and we have grams. So as I said, and we're trying to solve for pressure. So as I said before, this is the only thing we need to do is convert this to moles, because our units for PV equals nRT are moles, not grams. And then once we do that, we can just plug everything into the equation and then solve for P. So in order to convert grams to moles, I go 22.45 grams and then I do, again, the T-chart. So I have grams of argon, and I want those to cancel out and convert to moles. So I'll put moles at the top and grams at the bottom so that they cancel. And my molar mass for argon is 39.95 grams per 1 mole. So I divide 224.5 divided by 39.95, and I get 5.62 moles of argon. Okay, so now I'm ready to plug everything into my PV equals nRT. So P is the value I'm solving for. Volume is 15.0 liters. N, my number of moles, is 5.62 moles. R is that same value that we just talked about. And it's always helpful to just write out your units every time so that you are sure that they match up. And then temperature is 297 Kelvin. Okay, so to solve for P, I will multiply everything on the right side of the equation. And that will give me 136.8. And then I just need to divide by 15. And my final pressure will be 9.13 ATM. So again, make sure I have the correct number of sig figs. So here, this number has 4 sig figs, this number has 3. And then if I look over at my temperature, although 24 degrees Celsius does have 2 sig figs, I actually don't use the degree Celsius number. I only use the Kelvin number when I'm counting sig figs. So pretty much temperature is always going to have 3 sig figs. So I would just disregard degree Celsius and only look at the Kelvin number when you're counting your sig figs. So 9.13 ATM is the correct answer for that. So now go ahead and use these same principles to solve numbers 3 and 4 as best as you can, and then we'll go over them next class.